Hi there, my name's Lyle, and the system I have behind me is one of my main projects that I've been working on this year. This is a custom cell built around one of our brand new product lines, the ARS Flexibowl. Specifically, this is the Flexibowl 800. Sold out of Italy, this product is designed to replace conventional feed systems and is a unique version of a flex feeder. The major innovation in this product is that it allows part feeding, reorientation, and vision recognition to happen at the same time, all in the one system. This innovative product is compatible with every major robot and vision system and has a very accessible programming interface to change and test setting combinations for new and complex parts. It has been very easy to use and set up with a great technical support team behind it to help with more advanced applications. In short, this presentation will explain the simple setup and operating procedures and finally demonstrate its use in our custom-built cell. Before you begin setting up the Flexibowl, you must first find a power supply and an air supply. The setup is very simple. The first step to setting up is to supply the 110 to 220 volt AC major power supply, which runs the servos and other actuators within the system. You just want to take this cable that's supplied with the equipment, plug it in, and you're good to go. Then the second thing you want to do is take this connector, which you have to wire yourself for a 24 volt DC power supply. You're going to take it. It's a one-way connector, so you can only get the right way once, and plug it in. From there, you can go ahead and switch it on. These are the two main power supplies that are necessary to run this equipment. Okay, so this is the control panel located at the rear of the Flexibowl. Once you have your power supply, being the 24 volt DC and the 220 volt to 110 AC set up, you can go ahead and flick it on via that main switch right there. After about approximately 3 seconds, if there's no faults with the Flexibowl, it will turn green. Okay, so now that you have your power supply set up, you want to take an air hose with approximately a 6 bar pressure to it and plug it into the right valve, the right inlet, pardon me. The right inlet is the air in, and the left one is for the valve 2 functionality. The valve 2 is an air out, and it's used to redirect parts to the center of the bowl using an air blower. Now, with this pressure, if it's too much or too little, or you have no means of regulating it, you can take this white knob, pull it out, and adjust it, just like that. And once you've reached the desired adjustment, you're gonna push it in. After you hear that audible click, it's good to go. The reason you would want to adjust this air in is because when you use the flipping functionality that has 2 linear actuators underneath the bowl that push against the parts and try to flip it and reorient it, there may be not enough air behind it or too little air behind it, and the parts may not be flipping to the correct orientation. Okay, so now that you've set up the air, finally you want to connect the I/O. The I/O can be used via the Ethernet, which is this port right here, or you can use it via D-sub-9. I'm using it as a D-sub-9 because this is the most simple way to go about it, and it connects right into this port right in the middle. Flexibowl surface itself, we have some apparatus to choose. If we're going to flip a part that could potentially come off the side of the bowl, we can pick this flip guard. This comes standard with the Flexibowl. You can make your own. It's a pretty simple thing. Next, we have the redirecting brush. This is also a custom-made one. The one that comes standard with it looks like this. This is a custom redirecting brush that is rigid, whereas for softer parts that might slide easier on the surface, you can use a standard brush, which also works pretty well. ARS sells a number of surfaces which are very easy to remove. You just take out these 4 bolts here, pull off the cap, and remove these surfaces. The reasons you might potentially want to use a different surface involve the friction of the parts as they slide. Maybe you want to stop them earlier. We also have ridged parts to allow bumping and quicker reorientation of the part, and also there's a number of different frictions,
including but not limited to the white spike, the blue silicon, the blue negative diamond, and finally the standard thick white, each surface serving its own specialized purpose. Flexibowl also offers hoppers for seamless integration.
When setting up the Flexibowl, you want to first define the parameters with which it operates. So essentially what this means is how many times it rotates, what angle, and what speed. These parameters are usually custom per custom parts. When connecting, you first want to flip the switch up. If it is in this mode, you got to pull it out and push it up. This switch will define whether the Ethernet is communicating, the Flexibowl is communicating via Ethernet or I/O. So when we're setting up these parameters initially, we're doing it via a computer program, and we're going to connect that computer program via the Ethernet cable.
It is also necessary that you recycle the power for control method changes to take effect.
Okay, so here is the Flexibowl parameters program. As you can see, I've set the switch to Ethernet to allow control via Ethernet. This program, the purpose of this program is to set the parameters for use. So first step, I want to turn servo on. This will allow all motor movements. Here we have forward, there we have backward, and then you can shake. As you can see, each of these functions below it has a number of different variables that you can set. So I have angle, speed, acceleration, deceleration. Angle is obviously in degrees out of 360. So right now I'm using angle 90. This is obviously to move in quadrants, as is sort of easiest when dividing down a simple program. Shake, I have the clockwise angle, the counterclockwise angle, the speed, the acceleration and deceleration, and also the count. On top of that, you have the air functions. For the air functions, I can hit this flip 1. As you'll notice, it's doing 2 flips with a 200 millisecond delay in between. This is good for reorienting, and obviously you notice that if it's not reorienting the parts, I can change up the air, or if it's too violent, I can change down the air. It also, when I'm using a large amount of air, this flip guard right here comes in quite handy, as parts will be ejected from the bowl. Then we have blow. This is that outlet valve that you saw previously. This is where I'd want to sit it right here, and I'd blow the parts back in before they were coming through to the flip area and also the vision area. So obviously you can hear that sound. I don't have it set up, but it does come as a standard add-on with the Flexibowl. If you have a lightweight part, it's generally quite good, but obviously for heavier parts where there's more friction on the surface, the air might not move it as much. Okay, so once you've hit all the parameters you want to hit send parameters to Flexibowl. All this is doing is uploading all those parameters and allowing the Flexibowl to thus know that these are the settings that you want to have when you're activating it via the I/O. So when you send parameters to the Flexibowl, if you want to use it again, it will update, but you have to turn the servo on. You also have control of the light here. With the light area is right back here. And as you can see, that's an IR backlight, but you can also get visible light backlights of different colors, depending on your application. So the light's on, but we can't see it with the naked eye. Okay, so another thing that we use here at Schneider & Company is a sequence. When you send us your parts for evaluation on our Flexibowl, we have to find the best settings, the optimal settings. So as you can see, here I have on the screen the tri-sequence, which can be accessed from the tri-sequence button. This is useful in our testing. We offer part testing where you can send it to us at Schneider & Company, and we'll evaluate it, whether it's viable in the Flexibowl, and also we'll find the optimal settings for when and if you eventually purchase it. So here, to collect our data, we'll put it through a number of different settings combinations. As you can see, I'm just adding random scenarios to this. You can also add the delay. Here it has in the drop-down list all the combinations of possible parts. that you may or may not want to use, functions that you may or may not want to use, and it's a pretty intuitive interface. So when you've set up your sequence, which we use to collect data, I'm just going to hit try sequence. And as you can see, the Flexibowl will immediately start running through the sequence. So that is, in its essence, the sequence tool.
Here we have the demo cell in full operation. As you can see, it uses the 40-liter ARS hopper for feeding, the Flexibowl 800 series for orientation and separation, the Epson CV2 vision system for identification, and finally a custom 3D printed vacuum tooling on an Epson C4 robot for the pick and place with inbuilt secondary sensor verification. The parts being used in this demonstration are fender nuts from Ford. In this cell, the Flexibowl rotates in clockwise 90-degree increments, with a separating shake being used if too many parts overlap. The camera also dictates when the hopper should feed parts, if the overall count in a quadrant falls below a minimum threshold. Once fed, the parts are then rotated through a redirecting brush, which centers them to be flipped and reoriented, after which the parts are moved over to the vision area, with the backlight below and the camera fixed above. The robot then picks them up and uses a prox sensor on the tooling to check whether the camera properly identifies the correct orientation and places them in the target area or drops them back into the bowl on the rare occasion that the camera recognizes a part incorrectly. Thank you for taking the time today to learn about our new Flexibowl line. I hope you found this presentation informative.